Today we're going to be talking about section 4.7, which is on transformation of quadratic graphs. Now, so far we've talked about quadratics in standard form, when it was ax squared plus bx plus c. And that's one way that we can see quadratics. Another way that's a little bit easier to even graph is something called vertex form. And vertex form looks like this. And you'll see there's something distinct about it. There's this x minus h quantity squared. Right? And then there's also a k. And you'll see that that hk is the vertex of the parabola, and that h is the axis of symmetry. So some of the things that we looked for in quadratics, we can see right here in this form. Now, when we're writing something in vertex form, what we have to do is complete the square. Okay? So what we're going to look at first is this form right here. X squared plus 6x, and then the minus 5 just kind of hangs out. So just like we completed the square before, I'm going to put it in parentheses. And so I say y is equal to, now is there anything I need to take out of in front of the x squared? The answer is no. So I'm going to leave it like this. X squared plus 6x plus blank is equal to minus 5. Now before, when we were completing the square, because we were doing it on both sides of the equal sign, we added this. But since it's on the same side and we're not adding it to y, we need to subtract our blank. Okay, so do you see the difference? What we're doing is we're adding and subtracting on the same side of the equal sign. And so since we add and subtract, it's going to equal itself out. So I say, okay, well, what number goes in my blank? Well, we always said it was half of this number. So half of 6 is 3. And then we square that is going to be 9. And so since we're adding 9 here, we're going to subtract 9 in the back end. And so now the reason we do that, completing the square right here, is now this is a perfect squared trinomial. And so we can just write it out as the factored form, which is x, and that half of the middle number. Well, half of positive 6 was positive 3 or plus 3 quantity squared. And then minus 5 minus 9 is minus 14. Okay? So now that we have it in vertex form, we can answer a bunch of questions about our parabola before we even have to graph. Okay? So here is the form in vertex form of this equation. Same equation, just looks a little bit different. All right, let's look at another example right here. Part B says this. Okay, I'm going to put parentheses around the first two forms again. And so I say y is equal to, and now you'll see that there is something in front of the x squared that I have to take out, and that's minus 2. Okay, so I factor that out, and I'm left with x squared. Now, positive 8 divided by negative 2 is going to be minus 4x plus blank. And then minus 3 minus blank. And just like we did before, okay, so we said half of negative 4 is negative 2. Negative 2 squared is 4. And because there's something on the outside, I have to multiply it by 4 before I can put it in the blank. So negative 2 times a positive 4 is negative 8. And so you'll see minus and negative is really adding. So our final factored form, or vertex form of this, is going to be negative 2 on the outside. Now inside, perfect square trinomial, so we can do this x, and then half of minus 4 is minus 2, or negative 2, squared, and then minus 3 plus 8 would be plus 5. So we now have this in vertex form. Here are a couple guided practice problems. I'll have you try letter B. So if we're looking at letter B, the first thing we're going to do is put parentheses around the first two forms. Okay, I can see I take a 2 out of them. So y is going to be equal to 2 times the quantity x squared minus 6x blank, and then plus 17 minus blank. And so what's half of negative 6? Negative 3. Negative 3 squared is 9. 2 times 9 is 18. And so we get y is equal to 2 times the quantity x minus 3 squared, and then 17 minus 18 would be minus 1. So this is our factored form. Now, example 2. Now, if we have a graph, we can actually write the equation in vertex form significantly easier. Okay? So it goes like this. The first thing I see is the vertex. Okay, vertex is going to be 3, 2, which means if I'm writing it in this form, a times x minus h squared plus k, I know that h is going to be 3, I know k is going to be 2, and x is going to be x and y is going to be y. The only thing I have to find now is a. So I write it like this: y is equal to a times the quantity, x minus 3. Now the important thing is you notice that it is minus h, and then plus 2. Now how can I figure out what this number is right here? How can I figure out what a is? Well, luckily, we have another point on our graph, -1, -2. And so what I can do is I can actually input -1 in for x, okay, and -2 in for y, and that'll help me solve for a right here. Okay, so let's do that real quick. So y is -2 is equal to a times the quantity, -1 minus 3 squared plus 2. Okay, simplify it out just a little bit farther. -2 is equal to a. -1 minus 3 is -4. -4 squared is 16. So a times 16 plus 2. Keep going. I subtract 2, subtract 2. Now I get -4 is equal to 16a. Divide by 16. Divide by 16. And I find that a is equal to -1/4. And so now I go back to this equation right here, and a is really just -1/4. And so which one of these is the equation of my graph? It's going to be B. Here's a guided practice problem that you can try now. So since we know that h and k are -1 and -2, I look at my equation. Y is equal to a times the quantity, x minus -1, so that would be plus 1, and then plus a -2, or I'll just write -2. And then my other point is -4, 13, so I say 13 is equal to a times the quantity, -4 plus 1 squared minus 2, and so 13 is equal to a times -4 plus 1 is -3 squared is 9 minus 2. I add 2, and I get 15 is equal to 9a. Divide by 9, divide by 9, and I find a is equal to 5/3. Now I know that, put it in for a, and so I get 5/3 x plus 1 squared minus 2h is the correct answer for this guided practice problem. So let's talk about some of those transformations that happen when we have quadratics. Okay? First thing you'll notice, when we move h, okay, when h is positive, I move to the right. When h is negative, I move to the left. Okay? When k is my vertical translation, okay, that outside number. When k is positive, we move up. When k is negative, we move down. The next thing we look at is a, which is our dilation and reflection. When a is positive, it's a happy face. We kind of talked about this before. When a is negative, it's a sad face going down. And then a, when it's bigger than 1, it's going to be stretched or kind of squeezed in a little bit. And then when a is some fraction, okay, some positive fraction, it's actually going to be kind of, they say compressed vertically, but it's kind of like it widens out a little bit, right? So when a is a positive whole number bigger than 1, it's going to kind of be a lot skinnier, and then when it's a fraction, it's going to be a lot wider and fatter. So here's our next example. We're asked to graph this in vertex form. So what we're going to do is we're going to first put this equation into vertex form. Put parentheses around the first two. I notice there's a 4 in front of x squared. So I say y is equal to 4 times the quantity, x squared minus 4x plus blank, and then minus 40 minus blank. Alright, so we say, alright, well, what's half of -2? Half of -4 is -2. -2 squared is 4. And then we take 4 times 4. Okay, so that's going to be 16 right here. So this is going to be y equals 4 times the quantity x minus 2 and then squared minus 56. Now when graphing this, it's not a very good graph that we have on here or in your notes, but that's okay. We can still make it work. So first thing we notice is that the vertex is at the point 2, negative 56. Okay? So I go over 2 and then down, let's say that this is negative 56. So 2, negative 56. Okay? So that's my first point that I have on there. Now, the nice thing is we know that 2 is our axis of symmetry, right? So this dotted line right here, everything on the left is going to be the same on the right. So why don't we put in 0 and see what happens? Okay? So if I put 0 in for x, okay, this is going to be where my y-intercept is, right? So 0 minus 2 squared is 4. 4 times 4 is 16. 16 minus 56, let's say that this is the point 0, negative 40. Okay, and how did I find that? I just put it into my equation, put x in as 0. Okay, so if it's 2 to the left here, it's going to be 2 to the right here. So that would be the point 4, negative 40. Okay, so 2 units left, 2 units to the right. All right, so we can maybe try another one. Let's try, I don't know, let's say negative 4 right here. Okay, so negative 4 for x. So I put negative 4 in for x, negative 4 minus 2, negative 6, squared is 36. 36 times 4 is going to be, okay, so negative 3 minus 2 squared is 36, or excuse me, 36 times 4 is 144, minus 56, so this is 88. So negative 3 is going to be at like 88, which is like up here. Okay, and we can say the same thing, 1, 2, 3, 4, 5, 6 units to the left, so 1, 2, 3, 4, 5, 6 units to the left is right here. Okay, and so when we graph this, okay, it's kind of like this, and you'll notice that this is a little bit skinnier than most parabolas that we normally have, and that 4 on the outside means we stretch it vertically, meaning it's going to be a little bit skinny. And again, this is not a very good graph to try. Hopefully the ones on your assignment and the ones that you do later on will be on a little bit nicer graphs where you can actually put the points. All right, so here's a couple guided practice problems that we could sure try. And so if we look at 3a, you'll see that, okay, vertex is going to be at the point 3, negative 2. Okay, so if I was to make my coordinate plane kind of like this, all right? So 1, 2, 3, and then 1 down 2 would be right there. That's my vertex at 3, negative 2. Okay, now let's see if I put 0 in for x. Okay, put a 0 in right there. 0 minus 3 is negative 3. Squared is 9. 9 minus 2 is 7. Okay, so there's 0, 7 right there. And so axis of symmetry right here is at 3. And so since I'm 3 units to the left this way, I got to go 1, 2, 3 units to right there. And then we can just connect the dots. And we'll see if we have anything that looks just like